Hello and welcome to another video in this our simplified series. This should be our eighth video so far, and it has been an exciting experience. If you have followed this video to this point, I want to tell you that you are doing absolutely well and you're actually catching up really fast. I am happy for you. No pressure, just take it slow. So, today we are going to be talking about something super exciting. I personally find it interesting and exciting in the world of programming as a whole. Either I'm coding in Python, R, Go, JavaScript, C Sharp, C++. I love functions. I love functions. Whenever I hear the word functions, it just packs this thing in me like, okay, I'm about to start creating functionalities. So I'll just give us a quick breakdown or a story about functions that might want to excite you. But before I do that, you need to understand that everything the computer maps into its memory or into its working system is seen as an object. And you might have heard things like object oriented programming. So every object in the computer's perspective has a particular functionality. For example, the AC and the fan have similar functions. They both blow air, but then the air conditioning system blows cold air and it can blow warm air or ordinary air, but the fan just turns and just try to cool off the environment. If you don't understand that, look at your hand. Your hand is an object with different functionalities. You might fist your hand, you might wave your hands, you might raise your hands. You can do a whole lot of things with it. So, same thing in the world of programming, we have function. So, what is a function? A function is an aspect of a code that does a particular task. Now, I like explaining function this way so it's clear. The story behind is that it does something and returns something. You just call it, it does something and returns something. So there are two parts to functions: the function definition aspect and the function invocation or function call aspect. If you're able to separate these two, then when we get to where we are talking about parameters and arguments, it will be so clear, crystal clear to you. So let's get to it. How do we write a function in R? R, like every other programming languages, have that functionality. Either you're having a user defined function or a predefined function. We have been using print, paste, min, max. All these are predefined with R. But if you're writing yours, it's a user defined function. So to write it, let's say we want to write a function that will just say hello world. I understand the gods of the entire computer are actually jealous, so you need to greet them at every time. So let's greet them this morning in this video. I can just call it greeter. I use a search word. And to write a function, you need to call the function keyword. Pass a parenthesis, pass a curly bracket, and probably just do what you want to do in the function. And right now, we just want to say um, hello world. Perfect. As simple as this is, this entire aspect is what we call function declaration or function definition. If I want to see this function at work, I will just call it as a function and see what we have inside of it. So let's run this line and see. We have a function in our object. You can see our object is saying, yeah, greater is a function and it has something inside of it. So let me call it again. Can you see? Automatically it says hello world. There are two parts to this function: definition and call, or declaration and invocation, whatever means you see it. And in the declaration, we have the function keyword, we have the parentheses for our parameters, and our parentheses for our argument. So the difference between parameters and arguments is that at the point of definition, you set parameters. At the point of call, you pass arguments. Look at it like your car. Your car came with a fuel tank, but then for it to work, you need to put fuel to it. So we have parametric and non-parametric functions as the case may be. So let's move straight into talking about what default parameters are. Default parameters are like constants that you set in your function. The function requires a parameter, and if the parameter does not exist, it will fall back to a default parameter. Look at it like a fallback kind of system. Again, let's use the same function we have above and kind of pass a default to it. Maybe I say this function needs a name to work, and by default, the name should be, let me pass my name. So if I want to greet myself, instead of saying hello world, I can go ahead and say hello, and maybe I pass my name to it. And let's run this again. I'm calling this function. Can you see? It says hello Elijah. Hello Elijah. Now, Elijah in this context is a default parameter. You can see it's just more like a variable with a default assignment for a callback. So if I now call this function at the same time and pass Aliu, for example, and I run this again, can you see? It's saying hello Aliu. So if I don't pass anything, it uses the default parameter. If I pass something, it uses what I pass. I hope that is clear. Now moving to this quickly, the idea of a function is just to print out things or to, yeah, a function like I defined it, it does a particular thing and returns a particular value. So the beauty of function comes in the place of return. So we have function that's uh returns, we have those that just execute and just pass silently. So let's say we have a function that will just do an operation on two numbers for us and return the summation of two numbers. So let's call it summation, and I want it to be a function that would take two parameters, which are two numbers. Let me call it num1 and num2. To take this num2, num1 and num2, and probably you can add a variable to hold the result. Let's add that. It will go into result and say maybe num1 plus num2. So it will do a summation of num1 and num2, and at the end of the day, it will return uh, result. So this is a function. It will take all of this and it will return result to us. So if I go ahead and run this function, I can have a function summation. You can see it here. And the function summation, all it does is that it takes two parameters and returns something. So how can we make it work the way it is? So let's test it out. I can go ahead and say summation. Maybe I have two numbers I want to calculate, 23 comma 12. So basically if I run this, I will definitely not see anything. Oh cool, it works in console. Guys like Python and everything, you have to kind of say the print. So by running a summation, it takes this argument, passes it as a parameter, inject it into the function, and stores the result, and then uses the result and takes it back and give us in preview. You can see 23 plus 12, definitely 35. You might want to test it again, maybe 13 plus 12, whatever the case is. You can see it's saying 25. So whenever I call this function, it takes all these parameter arguments and has a return value. So that's a function with a return value. So whenever you call the function responds and returns a parameter. So now I've explained our parameters, our argument, and the return value. So for you to run a function or for you to have access to it, you just need to call the function and have it do something for you. So finally on this function aspect is global and local variables. It is important for you to know no matter what you're working on, some variables are global while others are local. Let's talk about the local and global variable. Like we said, the global variable available in all scope, the local variable always within functions, but then you can make a local variable be in a global scope. So how can we do that? If we have again a variable that says has eaten or something, um, you can make it true. This is a global variable. And if we now have a function that reports if somebody has eaten or not, um, we don't need to make it parametric. We just want it to return something. And inside of it, we have not 18, and let's make it false, for example. So this online 262 is global, while this online 265 is local. What do we mean by that? If I go ahead and say has 18, and let me run this so they all go to memory. Has 18, can you see it returned with true for me? What if I have not eaten? What do we see? Can you see? It said object not eaten, not found. So definitely the not eating, for me to see whether not eating, I must see through the function before I get to this particular local variable. So how can we make a local variable global? Is by simply having another less than sign, a double less than sign before values, or before within the expression, makes it a global. Okay, so we're getting this object not found. Let's see. Probably because I've not called this. So we can have it in our object as called and not eating false. So automatically this guy becomes available to us in a global scope. So let's test it out. What if we use just a single one? What happens? Okay, so it comes up for us again. So basically, if you want to convert a variable in a function to make it available in a global scope, we just pass it with a double less than sign, the variable becomes a global variable. So we have come a long way from introduction to data types to the string type, the boolean type, and we talked about loops, conditions, control statements, and here we are in functions. So we are done with the basics of getting to know R. Next thing we are going into data structures, and we are going gradually into what we can use R for, application of R in the world of data, application of R in the world of statistics. So stay tuned on this channel. See you in the next video. If you're yet to follow us, please follow us on YouTube, comment on our videos, switch on the notification bar so that when I will drop a new video, you'll be the first to see it. So I'll see you in the next video. Bye for now.